Hi everyone, in this video we will be designing a URL shortener. So let's start with the outline. We will start with the functional requirement, then jump on to the non-functional requirements, core entities, high-level design and deep dive. This is a basic template that we follow throughout this series. I have created a video on how I have designed this template and what all parts you need to focus most upon on your interviews. So let's start. Functional requirement. First, the user should be able to provide a long URL and get a short URL in return. The user should be redirected to the long URL when they enter a short URL. Third is URL analytics, like country, number of clicks, etc. So if a user clicks on a URL, then the person who has created the URL should be able to see how many number of clicks happened in a certain period of time, or which country the user belongs to who is clicking the URL. Now moving on to the non-functional requirements. So the non-functional requirements are as follows. First, short URL should be unique and short. So the entire use case of our URL shortening service is that you have a long URL and you want a short URL. So the short URL code in itself shouldn't cross more than 5 to 8 characters. 8 is also still on a higher side. I would prefer it to be at max 6 or 7 characters. And also the URL should be unique. So if someone goes ahead and puts google.com and they get a short URL, and then other user comes in and put google.com, they should get a different short code and not the same short code that the other user got. Next is redirection should be low latency. So any kind of redirection, like user comes in and give the short URL and you want to give the long URL or redirection, that should be very low latency, because if it is very high latency, the user will drop off from your platform and not use your URL shortening service. Third is that the system should scale to support 2 billion short URLs. So I've taken this number to scale, which is 2 billion. You can justify it in an interview by doing some mathematics around this. So you can say on a day there is 1 lakh or 100,000 URLs being generated, and in these many years or days 2 billion URLs will be generated. So we are going to scale up to that. Analytics should not impact URL redirection. That means analytics we are introducing that shouldn't increase the latency of the URL redirection. So this is kind of dependent on the second point, that redirection should be low latency, and as we are introducing analytics to our system, it shouldn't impact the overall key part of the system. Now moving on to the core entities. So core entities are pretty simple for this one. We have the user, the short URL mapping. So the short URL mapping will have a short URL code or the short URL itself. I would highly recommend you to keep only the short URL code, and then it will have the long URL, and the URL analytics will have something like the short URL mapping ID, which will basically be the short URL code itself, the click time and the country. Click time is basically when this URL was clicked, so when this was requested for redirection, and the country we can find out from the IP address. There are tons and tons of third-party services that would allow you to give the location information based on the IP address. API design. So these are going to be one-to-one mappings with our functional requirements. First one is the user should be able to provide a long URL and get a short URL in return. So for this we create a post API. Reason for post API is that this is going to create an entry in our database. That's why it's a post. The API will look something like this, /API. Then there is a versioning /shorten. So I've taken this name shorten to represent that in the request we will get a long URL. So this is our long URL, and in the response we simply will return the short URL to the user. Before we move on to the further API design, I just want to discuss one very important thing for the API design perspective here. So we are going to discuss the status code 301 versus 302. Both of these are used for redirection, but they have a slightly different purpose. So let's look at it. So 301 means moved permanently, and as per the official documentation, I'll read what it says. The HTTP 301 moved permanently redirect response status code indicates that the requested resource have been permanently moved to the URL in the location header. So this is basically that, hey, this URL is permanently moved to this particular URL now, particular location now. And moved permanently means that your browser will cache it, and there might be caching at the DNS level and so on. So you might have a lot of caching, and as a result if you once visit a URL and then you get 301 redirected to another URL, it is less likely next time when you go to that initial URL, you are going to have to reach the servers from where you will do the redirection. The browser will say, hey, I have it in the cache, let's go ahead from here. Next status code is 302, which means found. So I'll read through the official documentation. The HTTP 302 found redirection response status code indicate that the requested resource has been temporarily moved to the URL in the location header. So the main difference is here. The temporary keyword is the main difference here. Here, what we say is it is do not cache. So we are basically saying to the browser that, hey, do not cache this particular redirection. Maybe it will change in the future, or maybe we want the request to come to the backend services, because in our case, we also want the request to come to our service because we are doing analytics. And if here you do a 301 moved permanently redirection, then you won't be able to get the user analytics. So that is why we are discussing this status code 301 versus 302. I hope this is clear, and I'll move on to the API design now. So second functional requirement was user should be redirected to the long URL when they enter a short URL. So the API will be get, since we are not creating any entry in the table. Get API will be /API v1. The shortcode itself will be in the path, and the response status is going to be status code 302, and the long URL we are going to provide in the response. So the client can redirect to this particular long URL. Third functional requirement that we had was URL analytics like country, number of clicks, etc. So this will be an internal API. We have to note that it is not going to be publicly exposed because our redirection service will be making this API call and not from the external browser or external client. We are not going to make this because anyone can then come and copy that particular analytics API, start hitting that API, and our analytics will be skewed in that case. That's why we do not want to have this particular API to be publicly exposed. So the request for this one will be, before we start with the request, we go with the post. Post is because we are creating an entry in the database for this particular thing. Then /API /v1 /click is our endpoint. The request will be the short URL code. So something like this. And we will also get the IP address. So at the client level, you can take the IP address, or you can configure it at the Nginx level. There are various places where you can configure that, hey, I want a IP address for this particular request. The response will be just 201 created. So no returning back of any response body in this case, because we don't have anything to return. We have created an entry in the analytics database. Now let's move on to the high level design. High level design will be again one-to-one functional requirements mapping. So the first functional requirement was given a long URL, you want to get the short URL. So we have the user here, we have the API gateway in between. The API gateway will do routing, authentication, load balancing as well. And then it will move the request to the specific service. So it will be URL shortening service or shortening service in this scenario, and that will hit the database. So user will give a long URL. It will go through the shortening service. The shortening service will generate a random short URL, and then it will be stored to the database itself. Note that here I do not want to focus on how the short URL code is being generated. I'm just black boxing it that, hey, the short URL code will be generated randomly. So this is very vague on purpose. You do not want to deep dive into that part right now. You want to take this later during the interview and move it in the deep dive section to discuss it thoroughly. So you can let the interviewer know here, hey, I am putting it in a black box for now, but I will be coming back, because that is the core of this system. That is a really important topic that one should discuss. Next is, given a short URL, you want the long URL, which is the redirection part. So I'm creating a different microservice here for the redirection. So that is the redirection service. The reason I have created a separate redirection service than a shortening service is that they both have a different scaling need. The redirection service is read heavy, and the shortening service is quite write heavy and have very different scale. So they both have a different scale. I think the write service will have less number of requests as compared to the redirection service, because most of the user will be clicking your short URL and then landing onto the long URL, rather than there will be a few clients in comparison to the users clicking the long short URL. That's why they have a very different scaling needs. That's the reason I'm creating a different service here. Next is the URL analytics part. So we introduce one more service, which is the analytics service. And the redirection service will be calling this analytics service internally, like we discussed in the API design, that this is going to be an internal API and not publicly exposed one. So the redirection service, once it gets a short URL code, will be getting the long URL from the database, and eventually will make a call to the analytics service, passing it the IP address and the short URL code here. And then this analytics service will simply store the analytics inside the database. So we can see this is a very simple design right now, and it should be like that in the initial part of your interview. Your design should fulfill all your functional requirements like this one is doing, and then you move on to the deep dive section. So let's move on to the deep dive section. And the first non-functional requirement that we had was the short URL code should be unique and short, right? It suggests from the name short URL. So here the one is hashing. So how can you use hashing to generate a unique and short code? You use some kind of hashing function like MD5 or SHA-1 to hash the long URL. You take the long URL, you pass that long URL in the MD5 generation, hash generation algorithm, or the SHA-1, SHA-256, whatever algorithm you choose for hashing. And then you, in order to make it short, you, let's say, take the first 6 characters of the hash as short code. Like for SHA-256 or SHA-1, the first 6 characters are almost always going to be unique for 2 separate long URLs. That's the reason we are taking the first 6 characters, because there are probably no chances of collision in that case. The problem here will be not unique short URL. So for each long URL, because hash will always be the same for the given long URL, the same short URL code will be generated. But for our use case, we want that the short URL code should be unique for each long URL. So this approach won't work for us. Next approach, option number 2, is using UUID. So how this approach works, quite a simple approach. Generate a UUID for each long URL and use it as short URL code. So you take the UUID and then you say, hey, this long URL belongs to this UUID. Like, you are not providing any input to generate the UUID for that particular long URL. You are just saying, hey, at this moment, whatever the UUID generated in the system, that belongs to this long URL, right? And this can be problematic because UUIDs can be pretty long, and there is no good way to compress them to make them a short URL without having collision. So that's the reason why we are not going ahead with the UUIDs. I'm saying they are never supposed to have a collision, but yeah, it can be pretty long URL. So that's why we are cancelling the idea of UUID here, which is our option. Option number 3 is generate a random string. So how you are going to do this one? Take all possible characters, special characters included, generate a random string of length 5 to 8 and use it as a shortcode. Now, the problem with this approach is that high chances of collisions are there. You are generating a random string of 5 to 8 characters only, and this makes that your collision chances will be really high. I'm not going to show you the math, the probability, all those sort of stuff, but you can imagine that given such a short length, 5 to 8 characters, there are really high chances that 2 requests at the same time will have a collision. And as a result, if the collision is more, you will be going to the database again and again. You will make a round trip to the database for checking that, hey, is this URL generated, URL shortcode generated or not? If it is generated, I have to come back, generate a newer URL, and then check it again in the database. So here you are introducing kind of a check in the database for this particular thing, that check if the ID is already existing in database, then I will generate another random string. So this is one problem. Another one is, since you are taking all the special characters, this URL that shortcode will be generated will not be URL safe. As a result, it will be difficult to type the short URL because now you will have to encode your URL to make it URL safe. And you have to introduce like %20 for I think spaces or plus, and it becomes a complex one. So it now is not a short URL anymore. Option number 4, the recommended choice here is something known as a Snowflake ID with Base62 encoding. So I'll explain it. It's not very self-explanatory, as you can see. So what a Snowflake ID is combination of these 4 things: timestamp, data center ID, the worker node ID, and the sequence number. So sequence number is basically a counter. Each machine is going to have its own counter, and the timestamp and all these combination, data center ID, worker node ID, is going to be unique for each machine. That's how we are deciding that how the Snowflake ID is getting generated. You have to ensure that these things like data center ID, worker node ID are unique for each machine across data center. So this would eventually generate a very long code, and that long code is not sufficient for us. So in order to compress that long code into a shorter code, what we are doing is a Base62 encoding. The reason why we are doing a Base62 encoding instead of a Base64 encoding is because Base64 encoding can have special characters as well, and the Base64 will be longer as compared to a Base62 encoding. So for Base62 encoding, what happens is we take the characters A to Z, then capital A to capital Z, and from 0 to 9. We take all these character and encode our short code, Snowflake generated code, into a URL safe code. And talking about the number of possibilities that you can have with 8 characters is 60 to the power 8, which is 217 trillion URLs you can generate. Problem. Since everything comes with a problem, this one also have one problem. We could still have the chances of collision, which is very, very low. But here also you will have to make a round trip to the database to just check. Or what you can do is, you can make your short code as the primary key of the table and you do an insert operation. And if it fails, you generate another Snowflake ID. So that's how you are going to tackle this problem. And this is the recommended approach that I would suggest you to go ahead in the interview. Deep dive is here. So now we have introduced a counter here, you can see, which is inside the URL shortening service. So that will be used to generate the Snowflake ID in all the machines and eventually Base62 encode it and generate the shortcode. So this deep dive is next one is going to be low latency redirection. Now the bottleneck here for this one is that the redirection service is directly talking to the database to get the long URL. A very, very simple pattern here comes in is caching. You can cache the short URL to the long URL, and there's a benefit over here that you wouldn't have to keep a low TTL here. You can keep a pretty long TTL, since once a short URL is created, you can take a product decision of not being able to change that short URL, the long URL that is hiding behind that short URL. And you can say, restrict this to the user that once you create a short URL from a long URL, you can't edit what the long URL is. That allows us to do a really good performance enhancement. So what happens simply here, when the user comes with a short URL code, you check in the cache. If it is in the cache, well and good, you return the long URL, and the cache will have the key as short URL and the value as long URL. If it is not inside the cache, a cache miss, you go to the database, you get the short URL, and then you store your short URL to long URL mapping inside the cache. This is a very simple pattern for having low latency. And here we don't have to do things like eviction because we are not allowing the user to edit the URL map. Next up, the next deep dive is support 2 billion short URL. So here we are going to do some maths. Per record, I am assuming, so it's a valid assumption, I guess, to take 500 bytes per record, given that we are storing some metadata like created at the expiration time. Maybe we are storing some sort of long URL and short URL, of course. So I'm taking that per record, it will be taking 500 bytes. So for 500 bytes and 2 billion records, it will be 1 TB of data. 1 TB of data is not a lot of data for any modern SQL based system, and you can use any SQL database for this like Postgres, MySQL. But if your data grows to 1 TB, it is highly recommended that you shard the data across nodes. And to shard the data, you can use the short URL, since the cardinality on the short URL code is really high. You can use something like consistent hashing on the short URL as the sharding key, and then you can store the data in different instances of your DB, right? Next up is the deep dive, which is URL analytics should not impact URL redirection. The problem I have highlighted over here by this red arrow, the redirection service is calling the analytics service, and the analytics service can take a lot of time. So maybe the analytics service calls some external service to get the country from the IP address, and then it is eventually storing it in the database. So what we can do here is, in order to remove this bottleneck, we can introduce a message queue in between. So the redirection service, after getting the long URL for that short URL code, will just produce a message inside this message queue that, hey, this was the time at which the redirection was done. This is the IP address, and this is the short URL code and the long URL code that the redirection service can publish in a message. And then the consumer in the analytics service will consume those messages, then put in the database, and we are done here. The analytics service can take its own time now to call any external service or to get the country from the IP address. As a result, we have made this flow between the redirection service and the analytics service as async. So now the impact will be very minimal. Next thing you can do is to make your system a bit better. This is just a bonus point. You can use a specific time series database, since if you want to include, I would not recommend you include this part, but you might be showing user database where you would show the analytics, and you will show the analytics based on the time and the number axis, right? Number of clicks, and then your time will be in the x-axis. So for that, it's really recommended that you use some kind of an analytics DB or a time series DB to make things easy on the analytics service. And you can use a separate database here than your primary database, so you are not impacting by having of writes there. So I think that's it for this system design. I hope you liked it, and if you liked it, do like, share, subscribe, and thanks for watching.